Hello viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about overview energy from space. So let's dive deep into it. So what exactly is the problem? Well, right now our world is going YOLO on solar, and I mean everywhere. Be it China, be it India, everybody is going YOLO on it. And it will be fundamentally be the pillar of our energy infrastructure in the future. That part is sorted. So what about its carbon footprint? It's one of the least carbon footprint. Technically, it has already crossed a point where all the energy consumption in order to make the solar panel can be provided by that same solar panel. Meaning if you made 1 gigawatt hour worth of solar panel, that panels will produce more than 1 gigawatt hour, as in your factories, your machinery, all of those. And again, this was very recent, as in like 2015. Only then we crossed it. What about wind energy? It's almost there. People are saying it's almost like 70% has covered it. Almost. Yeah, like almost. So solar will be the future, flat out, absolutely, without any discussion, because we need three energy pillars, as in like any energy supply should have these three things, if not at least two things: cheap, abundant, available. Solar takes care of the two. It's cheap and abundant. Now here's the deal. Then should we use it? Well, here's the deal. It's so cheap it makes coal expensive. Flat out equations change. Everybody is going YOLO on solar. And at this point in time, if humanity covered every single human structure, pre-built human structure, meaning have a timer and stop everything, let's just say at the end of 2026 you stop a timer, no more human construction, no more new land acquisition, and cover every single human structure with solar panels, we will be done. Like, the only headache at that point would be interconnecting all of them, because consumption and distribution would be the hassle at that point. So solar will be our future. It is the least carbon footprint producing, as in like it's almost negative. People say that, but I do see we don't have mining trucks that run on electricity, so I get that point. But like, this is the best. There is no discussion. However, if somebody can crack that 24/7, basically cheap is already there, abundant is already there, available is not there. If somebody can crack that part, as in like make it available, all humanity's energy problem will be gone tomorrow. The end. Go home. Sweet dreams. So what if we go solar in space? What about space? Well, space has 24/7 into 5 billion. We good, brother. We good. We got this. You don't have to worry about it. We are sorted. This is a yellow giant or yellow dwarf. Something yellow. It should be fine for 5 billion years. So we have enough time. And trust me, when you actually go into space and you start to collect energy from a sun without any hassle of a planetary body, yeah, there is no energy source that can come close to that. Like, you want to make fusion reactor? We have free fusion reactor. Like, there is not even a discussion. It's just that 24/7 part that we have to solve. And be mindful, the solar panels, they are Mark 1 technology. We know how to make tri-junction solar panels. They are available. You can buy them. They are 51% efficient. We just don't mass produce them. They're only used for military satellite, or if you have like very, very bonkers amount of deep pocket, you can use that. And again, PVT is not mainstream yet. Again, for India, for hot places, having PVT is necessary, and it will allow us to run chillers on the solar thermal heat. So it will be like combined heat and power, far more efficient. At that point, carbon footprint would be minus, truly minus. So we have a lot of wiggle room. It's just that solve that part and go home. So overview energy, the worst name I have seen in recent times. If you type overview energy, Google tries to understand what you are asking. It's like overview of energy mix. It always tries to understand it. It's like very smart individual, but very poor name choice. So harness from space, and where it's 24/7 into 3. Basically, that's the whole essence. Put solar farm in space, or do something that allows you to harness energy from space. It was founded in 2022, so not a very ancient company, in Ashburn, Virginia, USA. CEO is Mark Bedry, this individual, and he's one of those people who would come up with a name like this. He's a nuclear physicist. Like, he actually knows nuclear engineering, like actually. And then he does aero engineering on top, and then he does defense contracts. So there are a few people who have like, I got this. He's that guy. So energy name makes sense. So why it's on everybody's radar? Well, because of Meta. Just everybody's like, okay, what if we put data center in space? It's like, that's stupid. We don't put data center under the sea, even though it will give you exponentially far more beneficial. Why? We have to pull it out every year in order to replace the GPU. Unwise. And you put it in space. When will you replace the GPU? either A, NVIDIA is lying that every generation of GPU is actually better, or B, you are screwed. So fundamentally, it always makes sense to have hardware on the ground. But power, that's the main issue, right? Power. What if your power is coming from space? So they have done a what you call memorandum of money part is top secret, but memorandum of understanding is that if you start to sell, we want dibs on first gigawatt. As in, like, once you cross the gigawatt, then you can sell to others, but we will be your first customer. And they are in early phase, let that be very clear. Now, they were in stealth because they were doing some testing. Once they got the testing result, as in, like, okay, this is here, this is real, now they are out of stealth. And so far they have already earned $20 million, and they have a prototype testing, as in, like, actual satellites sent to space and do that, because they did the airlines test, as in, like, from an airplane. They're gonna do the orbit test very soon, as in, like, it's already booked with SpaceX, a rideshare mission. So what's the principle of this? Well, principle is very simple. They have a big satellite, like a big puppy. Now be mindful, it's big, but it's not heavy. It's just a solar panel. And I'm pretty sure to keep the weight down, they're not even putting all the solar panel. What they have is a lot of reflectors. So it's almost like optimizing. It's like, either you can sell a lot of solar cells, which are expensive, or you can just sell aluminum foil. So it's like they're optimizing in that regard. So it's big surface area wise, but it's not heavy. So these are big satellites in geosynchronous orbit. Now, synchronous was chosen specifically because it's the cheapest orbit. Geostationary is expensive. Geosynchronous is cheaper. So they are going 35,000 kilometer minimum. And they're going to have multiple of satellites, as in these satellites could be 100-meter long. We have satellites that are this size now. So, and again, it's just solar panel, so it's not that big of a deal. And the idea is these will be collecting the sun, and multiple, as in they're not targeting 1,000, 5,000, it's like under 1,000. They should be fine. Now, again, they can expand it, or as things will mature, I'm pretty sure they can do a calculation. Let's say in the future, let's say 2040, if things are going as they are expecting, they could make a decision at that point. Hey, I think we can make much bigger satellites, or we can make much more smaller satellites. That's up to them. But right now, current target plan, like, near-term future, it's a lot of satellites, but not bonkers amount, not like million satellite. No. Lot of satellite. And it will take the solar energy, tada, convert it into near IR beam. Let that be clear. Infrared is a huge band. Problem with that band is that does not have a proper naming convention. So it has like, near infrared, mid infrared, far infrared. So they are taking a mid infrared. Be mindful, that means you cannot see it. Human eye cannot see. Your mobile phone can. Now, like, mobile phone can see infrared? Not mid or not far, but near infrared it can see. That's why it has a near infrared cut filter. Remove the cut filter, your camera will start to see that. So they are taking solar electrical energy, converting that into near IR beams via laser diodes, specific fiber diode lasers. Why that? Because they are efficient. As in, at this point in time, you can just pick up a phone, buy a laser diode, specifically, again, not deep infrared or mid infrared, below 1000 nanometers, that is 50 or 60% photon efficiency, meaning 1 kilowatt of energy consumed, it will give you give or take 600 watts of photons. That is doable today. You can do that today. So that's what they're doing. And how will you downstream the energy? You took the solar energy in space, great, converted into lasers, great. What then? Feed it directly into solar panels. And this is the critical part, because it's a monochromatic beam and it's according to them directly tuned for the band gap of the silicon, it will give you direct conversion efficiency, as in 50 to 70% efficiency is possible. Again, this is what they have tested, as in they flew a plane, had a solar panel on the ground, fired laser at it, and figured out how much energy what was getting, and with a lot of instruments, is like what is the flux and all that density. That's why they are out of stealth. They did it and it works out. Is that true? I do not know. Should it work? Yes, it's normal, known fact that if you can filter all the energy, basically just narrow band past the solar panel, it will be that efficient. That's like a known thing. It's like if you have a laser beam, you can transmit a lot of energy in a solar panel. That's like duh. It's just like coupling efficiency. And again, that's why people want to do with microwave. Coupling efficiency is easier. Here, it's not that great, but good enough. And the fact is, normal solar panel, as in the solar farm that pre-exist, you can shine a beam on it and it will start to produce electricity. However, you will not be able to see the beam. It's not like mirror or spotlight. We are gonna use a mobile phone to spotlight. No. You will not see the beam. So beam. And here's the deal. We are talking about giant solar arrays. We are talking about giant lasers. Is it safe for Earth? Well, yes, it's passively safe. What does that mean? That simply means if you look at it, you will not fry your retina. Like, wait a minute, can't you fry your retina if you look at the sun? Yes, because sun is a point source. Sun is a big ass point source, and it on Earth's surface can easily exceed 1000, basically 1 kilowatt per meter square. So when your eye is looking at that, your lens is creating a spot of a big ass spot that is roasting your eyeball. With this, each of the satellite, because it's far away, even with a IR laser, it will spread out enough. The long wavelength diffraction limit is like, whoa, it will spread out a lot. So that is there. And they're not targeting one super duper hyper beam. They're like, hey, what if you have lots of them? So each spot, because if you look at it, and even if hundreds of satellites are looking at it, it's almost like you are in a road and you have a lot of LiDAR based self-driving cars. And you're like, wait a minute, that's normal. Yeah, that's their essence, is that we are using IR, which again, LiDAR also uses the same wavelength. It's efficient. That wavelength, if it's coming from spots, and each spot is so far away that beam spread out is big enough, it will not fry your eyes. Like, you can keep looking at it. It's so below the threshold that it's harmful to look at the sun, which we all know, compared to this. And again, you won't even know where to look because it's not visible to humans. And that's the whole point, that 35,000 kilometer is buffering it enough. Now, having multiple basically input on a smaller area, what kind of oomph we are talking? We are talking about 300 to 600 watts per meter square, generally under that band. Now, like, wait a minute, would solar panel work? Yes. Why? Band gap. This is their claim. Let that be very clear. This part is the most hard to digest part, but if it works, if it is true that silicon band gap works as they are expecting or as their tests show, this could be big. Like, they could have solved the biggest problems. Like, you do not need a giant ground-based system anymore, and you will not need giant satellite, which is required for microwave system. It will not make sense in microwave to have multiple small microwave. It will make sense in this to have multiple small satellites. So even if one satellite goes kaput, you good, you fine. And that's what they tested, like that near IR. That's why they needed IR camera to test it. So this is the core principle of it. So what about the economics of it? Because again, I have tested time and time again. If you can't afford it, there is no point. So numbers of satellites are reasonable. Again, they're saying like we're gonna have thousands of them, which I'm pretty sure they will not. Again, that's far out. In near term, they are very reasonable. It's like we need few thousands of that. That I can digest, given the fact that SpaceX alone have launched thousands of it. So it's like, we good, we got this. And being in geosynchronous is cheaper than geostationary. That's also another wise part. Then why the heck go to geosynchronous, not be in low Earth orbit? There lies the main essence of them. If you are in geosynchronous, you have almost 24 into 7 into sunlight. When you are in low Earth orbit, you have 50% availability, unless you are in sun synchronous orbit, and that you have to spend a lot of fuel in order to stay that, because again your orbit will drift. So that limits your exposure, because sun synchronous creates a band, right? Daytime horizon. So you can, okay, I can give you in evening. They can shift. Basically, if you are in sun synchronous orbit, your mirrors or your reflector or light source only has the advantage of A, you are in low Earth orbit, so you can't steer the beam very far. B, you actually have only like a band, whereas like, okay, in the evening, late evening, I can provide you solar power. It's not like, why geosynchronous is like, bro, I got you. Like, technically you only need 3 satellites, but you won't do that with 3 satellites because each satellite has to cover almost what, 120 degree. It's a bit much. But if you have 10-20 of satellites, you can beam power anywhere on the planet. Any solar farm, you can beam power onto that. So that's the core advantage. And again, that gives you that beam separation without making it passively safe, which again, a desirable thing. So they, with multiple satellite, they're gonna have 24 into 7 into 365 solar coverage, as in space, they are never going into the shade. So if they are saying we're gonna give you power in this date and time, they can give you power in this date and time. If you are like tracking those satellites, they will look like they're moving in a figure 8 pattern. In geostationary, it's like, I got you. Your dish TV, where if you have remember those days, dish TVs, they have like, that's it, that's the dish TV. That's geostationary. Synchronous is like, so they do require some amount of what you call aiming. Basically, they will have a gimbal. So the idea is the diodes are laser coupled, fiber coupled. So the fiber will go into a telescope. Telescope will aim it where it needs to be aimed. And that's another reason, because their telescope is not going to be expensive. Why? Normal glass does allow that near IR window to pass through, basically that 900 to 1000 nanometer. That's why you need in your sensors IR cut filter. It passes through it. So fundamentally, that's the key. And your solar farm can work at night, no one be able to see it, and low energy density, meaning it's passively safe, meaning what if somebody flies through it, or just like somebody was jogging at the night and is like, oh, why I'm cooked. No, it won't happen. And 300 to 400 watts per meter square, it will feel like winter, like relatively speaking. So tech is inefficient. Let that be very clear. This whole procedure is very inefficient, but they said it very clearly. Solar is already cheap. It already works. Nobody is even trying to make a multi-junction solar cell which you can buy. Why? Because the starting price is so goddamn high. And here's a very simple example. You would think space launch is expensive, right? Which is. And you'll be like, okay, then we should optimize every gram. No, if you're expecting to launch thousands of them, you have to cost optimize. That's why Starlink satellites do not have those panels, as in multi-junction solar cell array. And again, that's why they are not even using xenon. They are using argon. It's cheaper. It makes sense. If you have to scale it up, economics change, and they're directly focusing on energy market, which requires everything to scale. So efficiency is not their selling point. Their selling point is availability. And then the final question, okay, you got the orbit part, you got the satellite, you have multiple satellites, so you have redundancy and you have full coverage, everything is good. What about the weather? That IR window, which again, the primary reason why everybody was focused on a microwave for so long, because microwave can just yoink through the cloud, so to say. This will not. That is factually true, and they acknowledge it. And they had a very practical answer. It's like, yeah, grid is bigger than the weather. And I'm like, damn, that's true. Again, for America. America is huge. Like it has like what, 3 or 5 time zones? It's huge. Meaning you generally do not have like, okay, I have a typhoon or tornado happening here. It's all solar farms are covered now. That does not happen. And again, we do not live on Mars where dust cloud will cover us for give or take 2 months. So you will always have some free open solar farm where you can like beam your light. And the idea is you beam based on bidding. You do not just like, okay, we're going to give you energy. Nah. The idea is they're going to utilize the market forces, because based on the demand, price is high. For example, you might think, okay, the night electricity price would be very high. Not really. It's the evening. Why? People come from office to home, every AC fires up at that point in time, and everything goes like full high load. But at night, everything is cooled down, ACs has already cooled it, people are sleeping, so demand is low. So you want to sell at that point, and they're gonna optimize it. Because they have so much wiggle room in where they can project their energy, the idea is like, oh, that solar farm will pay us the most amount of money, we're gonna aim there. And here's the deal, solar farms are already there. Already built, they're already working on their ROI. But if the solar farm can sell energy at peak time, peak demand, prices would be stupid high. So their ROI could go from 7-8 years to maybe as low as 3 years. That's how transformational the energy market is. And they are directly milking on that. It's like, we're gonna sell where it makes sense. Because why? What is the most expensive part? Solar farms? No, they are already there. And again, they are designed like all the solar farms have operational what you call vectors, where they're like, hey, we assumed some days will be cloudy. We assumed some days will not get a proper solar light. They assumed it. They assumed, planned for it, basically economically. They cannot do that. Like satellite must make money, because again, satellite is expensive. So it's like, what if you target it where you need to target it? Geosynchronous gives you a lot of wiggle room. It's like, bro, we have all the solar farm. Now, to be fair, because of the beam divergence and all that jazz, it does need big solar farms, as in multi-megawatt class. You're not send solar energy to my rooftop. That's not happening. It has to be multi-megawatt scale. I do not know how big, but it has to be. And all the gigawatt scale, that would be fine. So that's the economics of it. They're not targeting bonkers amount of satellites. They are not using low Earth orbit, which is already crowded. They are using the ways and the technologies that makes sense and optimizing for economic ROI. So what can we expect in the future? Well, all the technology I have covered so far in terms of space solar, this is one of the least out there idea, as in this is like least amount of cocaine was used, so to say. Now, focus on energy market for profit, that is the key essence. Like you need that. ROI is the critical essence for this sort of infrastructure kind of project. You need ROI. And if you can get ROI on energy, because again, solar is already cheap, already abundant. If you solve the availability problem, even if it's like available, they are very clear. It's like, let's just assume we made the solar farm availability from 22% to 70 or 80%. That's already transmutational. Like things will change if that happens. They do not even need 24 into 7 into 35. They just need like, 25% of the time you're working, you're already so effective. What if we pushed it to 60%? And be mindful, if you push solar farm to 60%, as in on time, those will cover the peak times. Money. So it has fundamentally what you call higher probability of ROI. There is no guarantee, but probability. And they're not brute forcing it. That was the most calm thing I've seen. There's not like, oh, we're gonna have like 1 billion satellites. Yeah, no. Reasonable, logical, digestible. So that's the good part. And target is 3 to 600 watts per meter square. That is again reasonable, logical, digestible. And all the components of it, as in that exact wavelength diodes, all of those are like off the shelf part. You can just buy it. So they do not need to invent like, okay, how the heck we're gonna make the rectina, how the heck we're gonna have microwave converters, all of that. Like they did that part is sorted. So we have all the solar we need, by the way. Let that be very clear. Assume in a future, let's say they cracked it. We're gonna end the energy discussion. We have the solar farms. Like the only thing after that would be, please increase the grid interconnection. So if when you are beaming energy from somewhere, it's like, oh okay, we have tornado there. It's like, okay, use energy into that farm, bypass it here. So we're gonna need a better grid, which again we have to need even if you have nuclear. It's not like you're gonna install nuclear reactor in everyone's home. You can do that with solar, can't do that with nuclear. So you're gonna need grid infrastructure anyway. So grid has to be rebuilt for like more oomph. But right now, if just let's say this works, it will be transmutation. It's like, whoa. So although everything would change, that is factually true, if solar farm starts to work based on our needs, not based on sun clock. They did use something that was like, press X for doubt. That like kilogram to orbit, they have two logical approach. One approach is they're gonna launch to low Earth orbit. Why? Because cost is known, things are known, is like take it and go. But if you want to send big puppies into geostationary or synchronous, it's expensive. But you can cheat it. Why? You are not a payload satellite. You are not like, okay, we have this telescope or this. You are just a solar panel. So what if you use the solar panel with ion engines to orbit raise maneuver? You have so much power. Like NASA is trying that nuclear reactor stuff that's targeting give or take 40 kilowatt of ion power. You have megawatts of power. So you can do station keeping, you can do orbit raising far more effectively, far more efficiently, cost effectively also, with using very small mass fraction of xenon or argon. So that's their far more digestible approach for a short term. For short term, they were saying like $2,000 to $3,000 per kg to geosynchronous. That's like SpaceX have already started booking for Starship. I'm like, bro, let them reach orbit, man. I mean, like, I can trust Blue Origin to send something into orbit, given the fact that they had 3 launches, 2 of them successfully deployed. So that's 3 to 2. SpaceX has like 11 to 0. It's like, let them reach orbit, man. So that's the part that I'm like, But these are the least what you call out there. It's far more what you call digestible, so to say. Again, it could work. But again, cost-wise, and again, optimizing on cost, that's a bit mean. It's like, imagine you're a small community. It's like, hey, if we can get power 24/7, everything is solved. It's like, no, you can't pay. Like, oh, that city is paying like, $8 per unit right now is peak high. We're gonna give it to them. But again, that's how grid works anyway. That's like yesterday. So let's see what happens. So this was my presentation on basically solar from space overview energy. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you have enjoyed it, please click the hype button. If you haven't liked it or enjoyed it, I would urge you to press the dislike button. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.